Hi guys, welcome back to part two of Ask Mike. And I have a familiar face here with me today, and Dottie. Today's video, we're kind of taking it back a little bit um, to our college days, and we're just going to share with you some of the basics of cell biology and how it relates to the COVID vaccine. But before we do that, Anne actually got her second dose of the Pfizer vaccine sometime last week. So, Anne, how did that go?
Yeah, so Friday I got my second dose and I'm fully vaccinated. And I think it was pretty seamless or smoothless for me. Still same thing, no real side effects, like a little soreness of the arm. But I put it this way, if you've ever had the Tdap for like tetanus, that was far more like painful than this one.
Right.
So it was a good experience.
Nice. Yeah, I actually I got the Moderna vaccine, so my turnaround is 4 weeks. So I'm scheduled for mine on the 26th, which is next week. So I'm excited for that. I'm excited to be fully vaccinated. I feel like time is going really fast because a lot of people who got their first dose already got their second dose. Um, and for those who haven't received the vaccine yet and are wanting to receive the vaccine, I'm going to be posting some information on where you can register. There are different places where you can register, but remember, it is according to your risk factors and things of that nature. So it might still take a while, but be patient, it's coming. Like I said before, we are taking it back to some college 101 scientific uh, principles and basics, things that we probably learned during our freshman year of college.
Yeah.
But just to kind of break some things down for you guys. We are going to start off by talking about the different parts of a cell. So, principles of bio, literally 101. Anne drew a nice little visual of a basic cell.
So no judgment.
This is basically a very rough sketch of what a human cell looks like. So if you look at the cell, you'll see different components. You see the nucleus, which is the biggest part of the cell, and that's where our DNA is housed. This is where the brain of the cell, the thinking of the cell happens. Um, and in the middle is the nucleolus, and that is also a component of the nucleus. And then we have the endoplasmic reticulum. It's kind of like a transport center for the cell. And then if you look at these little tiny dots on the cell, this is, by the way, the cytoplasm. This is where all the things in the cell are kind of held up. And those little tiny dots or studs are the ribosomes. So that is what the mRNA that we find in the COVID vaccine, that is the destination for this mRNA, and that's where the mRNA gets translated or packaged into a protein. And the protein in this specific vaccine, or in this specific case, is the spike protein of the COVID-19 of the viral particle. This is where, just to give you a rough idea, this is where all of this is happening. It's happening in the cytoplasm of the cell. Now, why is this important? This is important because a lot of people have a huge concern that the vaccine itself is going to alter your DNA. So, what I wanted you guys to see is that where this process is taking place in the cell, where the mRNA is getting translated into a protein, is away from the nucleus. Now, there are ribosomes in the nucleus, but for the purpose of this video, we're not going to get into that because those ribosomes serve a different function. But as you can see, the ribosomes are studied around the cytoplasm. We also have ribosomes on a part of the ER, which is one of the transport centers of the cell. There's a rough ER and a smooth ER. The rough ER is called the rough ER because it's studied with these ribosomes. But I just wanted you guys to get a basic idea of how the cell looks so that you can see, oh, okay, so this is where this is happening. It's away from the nucleus of the cell. And that is obviously where your DNA is stored. So then we have these little circles on the bottom left of my screen, called lysosomes. This is kind of like the recycling, or like the the discarding center of the cell. This is where the mRNA, once it's done being translated, once the message is read, this is where it's discarded. Now, the human body is amazing in that it doesn't like to build up waste. It doesn't like to hoard onto things, so it gets rid of it as soon as possible. And the lysosome is where all of this happens. Now, this is all very basic science. It's all much more complicated than this, but we just kind of wanted to break it down for you. So thank you, Anne, for the wonderful drawing. um, and now Anna's going to talk a little bit about something that I mentioned in the first video, which we kind of wanted to give a little more detail on, the central dogma and how it relates to mRNA.
So there's an image that will pop up so you guys can see it, but I'll just hold it for right now. The central dogma of molecular biology, which is like, I'm gonna geek out, nerd moment, one of my favorite things that we learned in that first year of school and continue to build our education on, kind of helps us understand how do you get from this DNA that everybody talks about that we can't see to like an arm or a person's full body, right? So here's our little example. The DNA was in the nucleus that Mike was talking about, that special, the big circle, that's kind of a special place within the cell that you have all of the information you need to create a body, right? The mRNA, which Mike was helping us see, is in the cytoplasm, that space outside of the nucleus where there's just those little dots and the other little organs of the cell, if you allow, that each have a special part in building up the process necessary to make the body. So you start with the DNA, you make an mRNA. mRNA goes outside and it comes with all the instructions needed to eventually get you to the protein. That, if you want to make it analogous to, is like an architect. The architect is the visionary. He's got this idea, or she has this idea of what they want to build. They're like, I'm going to build a housing complex. Right? So it's going to be 50 homes for people 55 and older. And in their mind, they see how the yard's going to look. They see how every house, some are 1 story, some are 2 stories. They've got this amazing vision. That's the DNA that's sitting in the nucleus. It's the entire plan for what is going to be. But in order to get from that vision and that plan of what it's going to become into, you need the architect to sit down at the computer and to draw it all out and create the blueprint. So if you allow, in this example, we're saying that the architect's mind is the DNA, all of the thoughts, the full plan. The mRNA is the blueprint, that small piece of it that says house number 22. This is what you need to build the foundation. This is what you need to build the first floor, the second floor, etc. That's the mRNA. And then the protein, the glob that you're actually going to see at the end of the whole processing system, is going to be the house, the home that someone's actually going to live in. So if you think of it this way, you start off with this plan in your head, this fully thought out, well idea, all the pieces you need without mistakes. Then somebody's got to draw it all out. That's the mRNA, it's the drawing out the small piece portion to get you to the full idea. And then you end up with the one home from that one mRNA. So that just one of the, say, 55 buildings that we said we were going to build, if that makes sense. So I don't know if you want to say how we bring it into the COVID vaccine.
Absolutely. So why do we build this picture? Why do we make these comparisons? Well, when it comes to the COVID vaccine itself, mRNA is that like main player in this case, because that's that set of instructions that is going to go to the cell and is in turn going to make that protein that we want. And what is this protein exactly? Like we've been saying, it's the spike protein on the COVID virus itself, and that is going to trigger an immune response, which is what we want in order for protection against the virus. And I think you had one more visual about the exactly. So in this case, the mRNA, just like the mRNA codes for the spike protein on the COVID virus, the vaccine serves as the instructions for that front door that Anne was referring to in our last analogy. So contrary to what some people believe, the COVID-19 vaccine, it's really not possible scientifically, physiologically, for it to alter your DNA. I know there's a lot of information going around saying that it's causing all kinds of crazy things, but what we know scientifically cannot alter your DNA. And this was the purpose of this video, to kind of help you see um, scientifically and through the cell how these things are working inside of our human body. Um, and so we hope that this kind of helped you a little bit and brought some perspective in terms of basic bio. We are also going to start going into some virology and some immunology, some little bit more complicated topics that we're going to try to simplify as much as possible for you. Again, Anne, thank you so much for helping me with this part of the video. And I hope that you guys enjoyed and also are informed and learned something today. We will be back with more information for you guys. Again, if there's anything that you're unsure of and you just have questions about, please feel free to reach out to me or to Anne. We are open ears and we will definitely lead you in the right direction in terms of information. So thank you guys again. Stay safe, stay healthy, continue social distancing, continue washing your hands, wearing your mask, and we'll see you soon. Thank you.